inverses of each other, say that the domain of one becomes the range of the other, and the range of one becomes the domain of the original. If functions are inverses, then they are also said to be one-to-one. They need to be one-to-one in order to be inverses, because you cannot have two y's that map to a single x. So for every x, there's only one y, and for every y, there's only one x. That's essentially what inverses are saying. They pass what we call the horizontal line test as well as the vertical line test. So they pass horizontal and vertical line tests, and they say that for every y, there's only one x, and for every x, there's only one y.
Built into like our system, and I was like, oh, so we don't have to do this anymore. I don't have to keep filling it up with water.
And now you just put it back sometimes. Water. Exactly. So you transfer them. It's just awesome. Yeah, because you just put it back right.
I don't know.
Every time.
Screencast. Alright. Are the following functions one-to-one? Would x cubed be one-to-one?
Yes.
Yes. Is x squared one-to-one? No. So just so you can see what they are, x cubed, way up. It would go through 1, 1, into 8. So there's your cubic, and here's your quadratic. So we can see that the cubic passes the horizontal and vertical line test, where parabolic passes vertical but not horizontal. Okay? So in order to find inverses, we go back to the most basic idea that in order to find them, you switch x and y and then solve back for y. So I put the directions down there. In order to verify if functions are inverses, you use composition, and the goal is to get the identity. So that means that if you had fog or goth, they should both equal x. Okay, show that functions are inverse functions of each other, then sketch both functions on the same coordinate plane. So let's look at f of x to start. We have f of x equals 2x squared minus 1. So what does the negative 1 tell you? Yeah, it starts at 0, negative 1 instead of 0, 0. What does the 2 out in front tell you? Yeah, it's much more narrow, right? So instead of going to up 1 and right 1, you have to go up 2 and right 1. And instead of going up 4 and over 2, we go up 8 and over 2. What do you know about the parabolic function? It is not one-to-one, right? So in order to make it one-to-one, what would you have to do? Yeah, we would have to restrict our domain. Let's determine what piece of the domain we would need to restrict. Do we want to make it positive or do we want to make it negative? And that's going to come into play based off of g of x. So you have to determine which side of the parabola we want depending on g of x. So let's graph g of x. So it is the square root of x plus 1 all 2. So, what? Yep. So, this is positive, so we're probably going towards the positive side of our parabola. So, we know that a square root function kind of looks like this. We also know that the domain and range of inverses need to be opposites. So, if on the original you have the point 0, negative 1, on its inverse you should have the point. Good. And then again, you could check, am I going to have the point 1, 1? Or am I going to have the point negative 1, 1? So if you plugged in 1 plus 1 is 2, 2 divided by 2 is 1, square root of 1 is 1. So you can see that we get the positive piece of the parabola. This is the point 2, 7. On my inverse, it will be the point 7, 2. Again, you could check that, plug in 7. 7 plus 1 is 8. 8 divided by 2 is 4. Square root of 4 is 2. So we have to restrict our red's domain so that f of x is x values greater than or equal to 0 only. Still okay? Good. That's the algebra of inverses. Let's look at the calculus aspect of inverses. Yes. Okay. Find the inverse of f of x equals x cubed plus 2. Is x cubed 1 to 1? Does the plus 2 change anything about that? No, it just shifts it up 2. So again, the idea is this is y equals, so we're going to make it x equals y cubed plus 2. So to find its inverse, we have x minus 2. Take the cube root. And we get y equals the cube root of x minus 2. How can we be sure if a function is an inverse of another function? What do we have to do? What? Yeah. So, like, you want to do function composition. So, take the original, plug in your new, and see if you get x. So, the original was x cubed plus 2. Where there's an x, we're going to put in the cube root of x minus 2. When you do function composition and you get it equal to x, this is known as the identity. So we get the identity function. So two functions are inverses and you get the identity, then we know we've gotten our inverses correct. We could also do the reverse of this, which is Goff. So that would be plugging in the x cubed plus 2 inside. So you get the cube root of x cubed, which still ultimately leads to x. Remember when you used to hate these and now you look at it and you go, it's so easy? You still hate them.
It doesn't matter how it's going to get harder.
So, graph the line y equals 4x plus 1. Graph the line y equals 4x plus 1. What's the slope of this line? So, start at plus 1. You go up 4 over 1. Then it says graph the inverse. So I want you to graph the inverse without calculating the inverse. So what that means is I want you to take all of your points and reverse them. So if this is the point 0, 1, on my inverse it becomes the point 1, 0. Go ahead. If this is the point 1, 6, right? Yeah. 1, 5. 1, 5, that's point 1, 5. On my inverse it becomes 5, 1. If that's negative 1, negative 3, on your inverse it becomes negative 3, negative 1. Negative 2, negative 7 becomes negative 7, negative 2. Looking at your inverses, what becomes the slope of the inverse using the, yeah. So if 2 9's on the original, what's on its inverse? Good. So the slope of the line at 2 9 on the original we know to be 4. The difference is that the slope of the inverse can be used calculating a point. So just again, another way of looking at inverses. And this idea right here, and the switching of points, is truly how we encompass it in calc. So in calc, we don't do the algebra aspect so much because in calc, derivatives and inverses and sines and cosine inverses become really, really messy. What's not really, really messy is taking a point we know and reversing it. So in calc, a big idea is being able to understand if this is on the original, this is on my inverse. So we take that idea a lot, and we're going to define it using P's and Q's to start. So it says, using the concepts from the previous example, I won't make it look so wrong. Using the concepts from the previous example, we can find the derivative of the inverse function without actually finding the inverse function. We use a new notation to describe this relationship. This different notation is used to describe the derivative of f at a point x equals a. So we are talking about the derivative of f, so we're talking f prime, at the point x equals a. So the derivative of f is f prime of x at x equals a. Or we can say the derivative of f with respect to x, and then use our new line notation and put the a. Do I staple them? Oh, because I gave you a table. To find the derivative of f inverse at a point PQ, we find the reciprocal of the derivative of f at the point QP. So again, I was stressing how important it is understanding that PQ becomes QP on the inverse. That's implied that the derivative of the inverse function at a point PQ has QP on its original function. So then we say the inverse derivative, so the derivative of the inverse with respect to x at point P is like finding 1 over the derivative at Q. So that's that idea of the slope is 4 on the original becomes 1/4 on the derivative. So the inverse derivative at point P becomes 1 over the derivative at q. I know. Take a minute to let that sink in. So if you're finding the inverse derivative at PQ, what we really do is take 1 over the derivative at Q. So if f and g are inverses, then their derivatives are at the inverse points are reciprocals. So that reciprocal concept, the 4 becoming 1/4. Remember, like the slope of the original is 4, the inverse slope is 1/4. Think about what does the derivative mean? The derivative means, what is another 3 words for derivative? Slope of the tangent, rate of change. So doesn't it make sense that if 2 lines are inverses, the slope of y equals 4x is the original, its inverse was 1/4, 1 over that 4? Yes? I want you to like that whole linear example is to help you understand this. Can we make that kind of connection with the 4 and the 1/4? So this is like the 4 to the 1/4. Okay. Well, let's look at an example. What's the first thing you probably want to do to get any points in calc at this point in the year? Take the derivative, right? Even if you don't know what to do, take the derivative. Take your derivative.
Which one? With the dx, the others,
Yeah. Implicit's on a pause.
I don't like implicits.
Part A says verify that 0, -1 is on the graph. So how do we verify that a point is on the graph? Plug it in. So what we want to do is plug in f of 0. And confirm I get -1. Because you know. Part B, find the inverse at -1. So in terms of our notation, that's like saying df inverse of dx at -1. That becomes 1 over f prime of 0. That becomes 1 over f prime of 0. Because that's like my p, that's like my q. So you write it as 1 over, so this becomes 1 over 5, 0 to the 4th plus 2, or 1/2. F prime of 0 in that other notation just looks like this. These two mean the same thing. Just to kind of, again, help that notation connection. Let's look at example 2. What do we want to do first? Yeah, find the derivative. All right, so you have an idea and you have an idea, and we got to do both. So we derived, and Josh nailed it. We have to solve for 2. We don't plug in 2. We have to solve for 2. Because this is like giving me the y, I need to know x. So it's 2 equals x cubed plus 2x minus 1. So we're going to say 0 equals x cubed plus 2x minus 3. Had a calculator. What's our rule from last year that would make finding this kind of easy? Anybody remember the rational root theorem? What if I rewrite it and I tell you P divides Q? So you take the factors of the last term and you divide them over the factors of the first term, and you use synthetic to find the roots.
I have no clue what
I
you're
don't know what synthetic is.
Yes, you do. All right, what two numbers multiply to give you 3? Okay, -1, +1, -3, +3. So your possible rational roots are going to be plus or minus 1 and plus or minus 3. What's usually an answer in most of these problems? We end up getting a 1 or a -1, right? Let's start with those. So let's pick 1 to start. Remember putting a number in a box over here?
Yes.
And then you write down the coefficient. So it's the coefficient of x cubed. Do I have an x squared? You bring down the first. Yeah, it's all coming back, right? This is synthetic. 1 times 1 is, so you multiply, then add. 0 plus 1 is, 1 times 1 is, 2 plus 1 is 3, 1 times 3 is 3, -3 plus 3 is, that's okay. So, synthetic division says you write down the coefficients of the term, of the polynomial. You pick one of these to put in your box. You bring down the first term. So I just take the 1 straight down. You multiply the box by the bottom number. So 1 times 1 is 1. Now I add the columns. 1. 1 times 1 is 1. Add the columns. 3. 1 times 3 is 3. Add the columns. 0. When we get a 0 at the end, we are super happy, because what that means is that x equals 1 is a root of this problem. So x equals 1 is a solution to that.
I remember I missed this lesson, and when I came back, I had no idea what was going on.
Because it's so. What that means is that when y equals 2, x equals 1.
I remember we had one problem with this whole test. I called it quits on it.
It means that you can take this and make it x minus 1, right? So move it backwards. These become the new coefficients. So that's like saying this is x squared plus x plus 3. So essentially you like factored out that x minus 1. And then you look at this and is this factorable? No. Factors of 3 that sum to 1. Yeah. So like the rational root theorem gets you the rational values. Remember like Descartes' rule where you have to like take the signs, and like if there's 2 positives and 1 negatives, it tells you you have 1 real root and then imaginaries. Okay. Maybe I'll like an algebra day. This right here is the solution to that without a calculator.
We do absolute
Just to make you feel better.
No, just to clarify.
Great booster.
So df inverse dx.
I feel like I don't know anything.
Oh no, don't go that way. df inverse dx at 2 becomes 1 over f prime of 1. df inverse at 2 becomes 1 over f prime of 1. So that's like 1 over 3, 1 squared plus 2, or 1/5. So what that means is the slope of the tangent to the inverse is 1/5 at x equals 2. We are not going to do the trig ones today.
Good. Because I barely.
Trig is tomorrow.